Biogeochemistry is the scientific discipline that involves the study of the chemical, physical, geological, and biological processes and reactions that govern the composition of the natural environment. In particular, biogeochemistry is the study of the cycles of chemical elements, such as carbon and nitrogen, and their interactions with and incorporation into living things transported through Earth-scale biological systems in space through time. The field focuses on chemical cycles which are either driven by or influence biological activity. Particular emphasis is placed on the study of carbon, nitrogen, sulfur, and phosphorus cycles. Biogeochemistry is a systems science closely related to systems ecology. History. The founder of biogeochemistry was Ukrainian scientist Vladimir Vernadsky, whose 1926 book The Biosphere, in the tradition of Mendeleev, formulated a physics of the Earth as a living whole. The Vernadsky distinguished three spheres, where a sphere was a concept similar to the concept of a phase space. He observed that each sphere had its own laws of evolution, and that the higher spheres modified and dominated the lower, abiotic sphere, all the non-living energy and material processes. Biosphere, the life processes that live within the abiotic sphere. Noesosphere, the sphere of the cognitive process of man. Human activities modify the biosphere and abiotic sphere. In the contemporary environment, the amount of influence humans have on the other two spheres is comparable to a geological force. Early development. The American limnologist and geochemist G. Evelyn Hutchinson is credited with outlining the broad scope and principles of this new field. More recently, the basic elements of the discipline of biogeochemistry were restated and popularized by the British scientist and writer James Lovelock under the label of the Gaia hypothesis. Lovelock emphasizes a concept that life processes regulate the Earth through feedback mechanisms to keep it habitable. Research. There are biogeochemistry research groups in many universities around the world. Since this is a highly interdisciplinary field, these are situated within a wide range of host disciplines including atmospheric sciences, biology, ecology, geomicrobiology, environmental chemistry, geology, oceanography, and soil science. These are often bracketed into larger disciplines such as earth science and environmental science. Many researchers investigate the biogeochemical cycles of chemical elements such as carbon, oxygen, nitrogen, phosphorus, and sulfur, as well as the stable isotopes. The cycles of trace elements such as the trace metals and the radionuclides are also studied. This research has obvious applications in the exploration for ore deposits in oil, and in remediation of environmental pollution. Some important research fields for biogeochemistry include modeling of natural systems, soil and water acidification recovery processes, eutrophication of surface waters, carbon sequestration, soil remediation, global change, climate change, biogeochemical prospecting for ore deposits. Representative books and publications. Vladimir I. Vernadsky, 2007. Essays on Geochemistry in AMP, The Biosphere, Tr. Olga Barash, Santa Fe, New Mexico, Synergetic Press, ISBN 0-907791360. Schlesinger, W. H. 1997. Biogeochemistry, An Analysis of Global Change, 2nd edition. Academic Press, San Diego, California. ISBN 0-12-625-155-X. Schlesinger, W. H. 2005. Biogeochemistry. Volume 8 in Treatise on Geochemistry. Elsevier Science. ISBN 0-08-044642-6. Vladimir N. Bashkin, 2002, Modern Biogeochemistry, Kluwer, ISBN 1-4020-0992-5. Samuel S. Butcher et al., 1992, Global Biogeochemical Cycles. Academic, ISBN 0-12-147685-5. Susan M. Leibs, 1992, Introduction to Marine Biogeochemistry. Wiley, ISBN 0-471-50946-9. Dmitry Malyugov, 1995, Biogeochemical Methods of Prospecting. Springer, ISBN 978-0306-106828. Global Biogeochemical Cycles, a journal published by the American Geophysical Union. Biogeochemistry, a journal published by Springer.